Welcome to the video for lesson 10.1, where we are going to be learning about the properties of a tangent to a circle. And grab your pencil and write in the learning target, please. I can use properties of a tangent to a circle. The first thing we want to do is we want to go over these vocabulary terms, which I think you should be familiar with due to the fact that we did the vocabulary assignment in class. And our first term here is circle. The circle definition is set of all points in a plane that are equidistant from a given point. That given point is called the center. So whatever the name of the center is, let's say it's W, we can draw a symbol that represents a circle and call it circle W. The next vocabulary term we have is radius. A radius is a segment whose endpoints are the center and any point on the circle. Again, a radius is going to be 1/2 of the diameter of the circle. And our third vocabulary term is chord. And a chord is a segment whose endpoints are on the outside edge of the circle. So if I draw a circle and I make a line like this, that segment is going to be called a chord. And to notate a chord, if this is point A and this is point B, we would call that chord AB, and we would want to put a symbol just like we would when we name a segment. Our fourth vocabulary term is diameter. The diameter is a chord that contains the center of the circle. Just a reminder that that chord is going to be the longest chord. So it is kind of a special chord because it is the longest chord. Our next term, secant, is a line that intersects the circle in 2 points. So it's a line. Okay, what's the difference between a line and a segment? Well, a line goes through and continues on. So a secant is going to be something that touches it in 2 places, but it also is going to be something that continues on past the circle. And that's the difference between a secant and a chord. Tangent, which is going to be the focus of our lesson, is a line in the plane of a circle that intersects the circle in exactly 1 point. And that point is called the point of tangency. So we're going to have lots of examples today about tangents. Those are lines, segments outside of the circle, not within the circle. It's only going to touch the circle at 1 point. All right, let's take a look at Theorem 10.1. It says, in a plane, a line is tangent to a circle if and only if, remember this abbreviation says if and only if, the line is perpendicular to a radius of the circle. And remember, this symbol right here means perpendicular. We'll take a look at an example dealing with Theorem 10.1. Theorem 10.2 says tangent segments from a common external point are congruent. Again, we're going to take a look at an example of this as well. So now that we have the basic information that we need to continue, we're going to take a look at a few examples. There's 4 examples that we're going to do, and then of course there are some practice problems I'd like you to try on your own. All right, for example number 1, we are going to identify special segments and lines. So we've already defined the word radius, chord, diameter, secant, and tangent, and we know what this symbol means. It means that we're talking about circle P, because P is the center of this circle. Now, I would like you to stop the video and I would like you to think about what is the segment RT on the picture. What is the ray WT? So in terms of what vocabulary term is it? So name that type of figure in the diagram. So what segment is PT? Is it a diameter? Is it a secant? Is it a chord? Is it a radius? And also line RQ. What part of the circle is that, or what part of the diagram is that? Go ahead and stop the video and try to fill these in on your own before I reveal what they are. Okay, we're back, and I hope you have identified each of the segments or lines or rays that we see here. And let's just take a look For the part A, RT is a diameter. That's the longest chord that goes through the center. And ray WT is a tangent. It only takes and touches the circle P in one place, and that is right here at the point of tangency, which is point T. Remember, a tangent is outside of the circle, completely outside of the circle, and it's only going to touch the circle in that one place. All right, a radius, PT, which is right here, kind of already marked. And then the secant is going to touch the circle in two places, and again, it goes through the circle. And just a reminder then that this is going to touch in two places, or we could say 2 points of contact with the circle. All right, that's a good way to remember the secant. All right, for the practice part, for problems 1 and 2 here, I'd like you to identify what QR is. So use one of the vocabulary terms to identify QR, and it is not going to be the same as part D here because it looks a little different. It has just the segment mark on it, not the line. All right, and then also I want you to identify what PR is in the circle diagram above. And then for part 2, use the diagram in example 1 and name a tangent. Name a tangent. Remember, it has to touch the circle in just one place. All right, going on to example 2. Find lengths in circles in a coordinate plane. So if we're looking at the coordinate plane given to us, we see lots of circles. We see circle P, circle Q, circle R, and circle S. And it's asking us to find the diameter and the radius of a couple of these. So we'll take a look at the diameter. Remember, it's the chord that goes straight through the center. And if we're looking at P, looks like we are at 8 at this edge of the circle, but we're at 0 at this edge of the circle. So if we go right through the center, it looks like the diameter of circle P is 8 units. And the diameter of circle Q up here looks like y is equal to 16, and if we go right through the center down to 0, then that means the diameter is going to be 16 units. And if we look at the radius, recall that the radius is only 1/2 of the diameter. So if we go back up here and look at the diameter being 8 units, then that means the radius is only going to be 4. Same thing with part D. We already identified the diameter of circle Q is 16, so half of that is going to be 8. If you would please turn your paper over and we're going to look at example 3. Example 3 is asking us to draw common tangents. I just want to remind you that a tangent is a line or a segment or a ray that comes in contact with a circle in just one place. So it has one point of tangency. And in order to make this a little bit easier, let's use a ruler. So you're looking for how many common tangents the circles have. So that means a tangent that would touch both circles, but of course only touch them in one place. So for part A, it looks like there's one common tangent right here because it's touching the circle in this spot as well as in this spot. And we also have a common tangent running underneath the two circles right here because this tangent touches the circle here in one place and here in one place. Okay, so there's just 2 common tangents for part A. How about for part B? Looks like because the circles are separated, we're going to be able to get a line of tangency in between going this way. That's one of the lines that we can draw, but we can also draw one the other way. Whoops, I missed my first circle there. So be careful. You're supposed to try to get them to touch just that one spot of the circle. Okay, then we also can do the same thing which we did in part A, go on top and also underneath. And again, these should just be touching the circle in one point. I know they can be a little bit challenging, but if you have that straight edge, it's going to make it a lot easier. Now for part C, it's a little tricky. these circles are inside of each other, and so really they only touch each other in this one spot over here. So that's where my one spot is going to be that I can draw that tangent, because it's going to contact both of those circles right there. So we could only have one common tangent for those two circles there. All right, let's take a look at example 4. You may recall the Pythagorean theorem, and that's really what I'm going to be using here for this problem, because we're looking at, it says here to verify that the tangent is really a tangent. Well, what if AB is our radius? AB is 8, okay, in the problem. So if that's the radius, and we know that the only way for line BC or segment BC to be a tangent is it has to be perpendicular to the radius. Okay, so there has to be this perpendicular relationship between the radius and the tangent if it's truly a tangent. And it looks like to me that BC is 6, and then we have this other length over here which really doesn't have a defined name, but it is 10. So AC would have to be the hypotenuse of that right triangle there, and it is 10. So we're going to use the Pythagorean theorem. Remember, a squared plus b squared equals c squared. So let's check out and see if this actually works. If it does work, then BC is a tangent. If it doesn't work out, then BC is not a tangent. Okay, these are our two legs. So we're going to use those as our legs, and this is our hypotenuse, which is going to be c. All right, so we're going to take a squared, which is our radius, and that supposed side that's a tangent is 6 squared. And does that equal 10 squared? Well, let's work this out. 8 times 8 is 64, 6 times 6 is 36, and 10 times 10 is 100. Is this actually true? Does 64 plus 36 equal 100? And if we use our calculator, we can verify, yes, BC is a tangent, because the Pythagorean theorem makes a true statement there. Okay, for these notes to be completed, you're going to need to finish exercises 3, 4, 5, 6, and 7. These are going to be similar to the example problems I just did with you. So if you would please, I would like you to find the diameter of circle R, and circle R is on the other side of the page, like the ones that I did with you. And I also want you to find the radius of circle R. So that's just going to be half of whatever the diameter is. And then I also want you to find the same for circle S and the radius of circle S as well. So the diameter and the radius of those two circles on the other side. I want you to draw in the common tangents and tell how many you have for each one of these problems, 4, 5, 6. And then finally it says here in for number 7, using the diagram in example 4, is segment BD tangent to circle A? So what you'll need to do is take a look at this other triangle. So I'm just going to outline it, and basically what you need to do is use the Pythagorean theorem and tell me, is BD, this segment that's 15, tangent to the circle? So if the Pythagorean theorem comes out correct, then you can say yes. If it does not make a true statement, then the answer is no, that BD is not tangent to circle A. All right, try those last 4 problems, please, 5 problems, and thanks for watching.